we're going to go on and get started. They'll probably do the announcements here in a minute. Okay. All right, guys, are there any questions over any of the assignments thus far? Any questions over any of the assignments so far? So we're finishing up this chapter with 664. So today we're doing 662, tomorrow 663, and 664. All of these sections and the one we did last Wednesday are all going to revolve around solving these logarithmic and exponential equations. Now the first problem we're looking at is this one here. 2 to the x is equal to 7. 2 to the x is equal to 7. Now with the ones that we solved last week, we rewrote them so that the bases were the same. But for this one here, there's no way that we can rewrite 7 as 2 to a power. It just doesn't work. We can't rewrite 7 as 2 to some power multiplied by itself a certain number of times. But what we're going to do is something a little bit interesting. One of the properties that we had with using logarithms was log base b of b. Whenever the base and what's inside the logarithm are the same, this equals 1. Whenever the base and what's inside the logarithm are the same, it simplifies to 1. So we want to apply a logarithm where the base and what's inside are going to match up. So for this here, what we're going to do is apply log base 2 to both sides. So what that'll give us is log base 2 of 2 to the x is equal to log base 2 of 7. Now on the left-hand side, this exponent is going to go out front. As part of our properties of logarithms, our power property states that if there's an exponent inside the logarithm, we can move it to the front. And by doing this, what we get is x times log base 2 of 2 is equal to log base 2 of 7. Any questions on this so far? Now we can calculate these here. So if I wanted to calculate log base 2 of 2, we can go math log base 2, 2. So log base 2 of 2, which gives us 1. So log base 2 of 2 is 1, which really just leaves us with x is equal to log base 2 of 7. Now we can use the calculator to calculate what log base 2 of 7 is. So we can go back into math, log base 2 of 7, which turns out to be 2.807, and it continues on. This is not going to be a nice number. But for this here in the homework, we're going to go 3 decimal places. So that's it. Now we could have used the change of base to calculate log base 2 of 7. So we could have plugged it in as log of 7 over log of 2, and that would have gotten us to the same answer. So for some of the calculators, if you have one at home or some on your phone that don't use log base, where you can't just type it in as log base 2 of 7, we could type it in as log of 7 over log of 2 and get to the same answer. Any questions on any of this here? What do we think of this so far? Is this as bad as y'all thought this was going to be? Let's look at the next one. 3 to the x equals 8. So what can we apply to both sides? Log base 3 of x is equal to log base 3 of 8. And we're using this so that we can simplify the one side out. So on the left-hand side, we can move the exponent up front and have x log base 3 of 3 is equal to log base 3 of 8. And as we said so far, log base 3 of 3 simplifies to what? 1. So that just leaves us with x is equal to log base 3 of 8. So we'll want to approximate the decimal. Now for the test, I would definitely, let me get a highlighter, make sure to include this as part of your answer as one of your steps going down, because some of the ones that we'll do in a little bit are quote unquote more complicated. There's going to be more with it. So it's easier to make simple mistakes in the calculator that will get you to the wrong answer. Because a lot of these, with dealing with exponents, the slight change of a sign, or instead of putting 8, you put in 18, is going to make a vast difference in the answer. So if you do have this here as part of your answer, I know that you got to the right answer. It just means somewhere between this here, it was a calculation error. That wasn't something that y'all solved it wrong. You just typed it in and something happened there. So here we can say, kind of cursor up here and grab the log. We know what's inside here is 8, and it's not 2 anymore, it is 3. So we get 1.893. And that there would be the answer. And that's all we have to do for this here. Any other questions on this here so far? Now to do this, we do need to have one base on either side, one number on either side. If we have more than one, we need to try to simplify it if we can. Here, we only have one, so that's kind of nice. So what can we do first? We can apply log of what? Log base 7 to both sides. Log base 7 to both sides, because log base 7 of 7 will simplify to 1. And because of our properties of logarithms, we can move that exponent out to the front. Yes? Well, this a little earlier than I did in the last class. What is log base 7 of 7? 1, because we're applying that so that it cancels out, yes? Is there any reason that I need to rewrite log base 7 of 7 at this point? No, because we know this is gone. And this here is equal to log base 7 of 15. Now, in all the ones previous, at this point, x was by itself, yes? Is x by itself? No. What do I need to do to get x by itself? Divide by 9. So that's just telling us x is equal to log base 7 of 15 divided by 9. And again, at this point here, we can plug this into the calculator. So we can go alpha y equals inner to get our fraction. Math log base 7 of 15 divided by 9. We get 0.155 if we round to the nearest third decimal. And that there would be our answer. That's all we would need to do for this here. Any questions on this here? If we weren't using the graphing calculator and we needed to do this by, in the yellow calculator, we could do log of 15 divided by log of 7 and divide that by 9 and get to the same answer. We can break it up into different parts and do that there. But on any of these here, once y'all start doing the calculations, do them all at once. Do them all at once because, as we've seen so far, logarithms, except for a small group, don't give us nice numbers. We get these ugly decimals. But any other questions on this here? Are you ready for the next one? We'll look at this one here and then we'll move on from this here because I feel like probably y'all are getting the hang of how these work. For this one here, what are we going to do to both sides? We'll apply 5. Here we're going to have 5 to the equals log base 5 and 311. On this side here, the 3x plus 7 would move out to the front. It would simplify to 1 and cancel out. We won't have to rewrite it. Mainly because 3x plus 7 times 1 is just 3x plus 7. Is equal to so really the main thing that we're learning or kind of going over today is so far just applying that log base to get the variable by itself. Now we need to solve for the value of x. What can we do first? Minus or subtract 7 from both sides. Here, 7 minus 7, 0, leaving us with 3x is equal to log base 5 of, you all know, 311 minus 7. Because again, that 311 is inside that logarithm, and we applied it to it. Because log base 5 of 311 minus 7 and log base 5 of 304 are two separately different numbers. And lastly, we would divide both sides by 3, which will tell us that x is equal to log base 5 of 311 minus 7 all over 3. Now, as I said earlier, some of these here, like the first two we did, typing those in is not too bad, and coming up with a mistake is not as likely. Here, you're more likely to make a mistake if you're not paying attention, because we do have to close that parentheses. Log base 5 of 311 does need to be together, not minus 7. Because if we don't include that second parentheses, and the calculator will include both, it would subtract the 7 first, and then divide, then apply the log base 5, then divide by 3, which is not what we want. So if we type this into the calculator, well, we'll need a fraction to begin with. Then we can go math. So we'd have log base 5 of 311 minus 7 all over 3, which gives us negative 1.145 because we would round up. Any questions on this here? Any questions over anything we've done so far? Do we need to see another example of one of these here? Or do we feel pretty comfortable with this here? Okay. Let's look at these here. These here are a little different because for one, we're using e, but we also need to get e by itself. So to get e by itself, well, the first thing I'll need to do is plus 7. Because anytime we use here, we'd use ln, we need one term on either side if we can get it there. Especially, we need to get everything away from the term with the variable as an exponent. So here we need to add 7, which will tell us that we have 4 times e to the negative 0.3x is equal to 20. Is it by itself? Well, no. We need to divide both sides by 4, which will tell us that e to the negative 0.3x is equal to 5. Because we want one term on both sides if we can get it, or at least get everything else away from x. Any questions on how we got to this point here? Now at this point here, we do need to get rid of the e or simplify the e. So what we can do is apply ln to both sides, which would give us the natural log of e to the negative 0.3x is equal to ln of 5. Now our negative 0.3x will move to the move out front, which would give us negative 0.3x times the natural log of e is equal to the natural log of 5. Now the natural log of e is 1. That simplifies to 1, telling us negative 0.3x is equal to ln of 5. So last but not least, to solve this here, we would divide by negative 0.3. That way, these here simplify to 1, giving us x is equal to the natural log of 5 over negative 0.3. Any questions on this here? Now at this point here, we can type this into the calculator. So alpha y equals enter. So we'd have ln of 5 divided by negative 0.3, which gives us negative 5.365. Negative 5.365. That's it. Now our answers for these here can be positive, negative, or 0. It doesn't matter because we're talking about the exponents. Because we can have negative numbers in the exponents. We cannot have a 0 or negative number inside of a logarithm or natural log. Any other questions on this one here? All right, let's go on and look at the next one. And then we'll go on and move on from here. So we have 3e to the x minus 4 is equal to 8. So again, the first thing we need to do is to get e by itself. So the first thing we can do is to add 4 to both sides, because we need to move everything over with addition and subtraction first. Doing that will tell us that we have 3e to the x is equal to 12. Then what can we do next? We can divide both sides by 3, which will tell us that e to the x is equal to 4. Now we do have e by itself, yes? So that means we can apply the natural log to both sides, which will tell us that we have ln
Over here we have ln of e to the x is equal to the natural log of 4. Now again, just like with the ones before, the x would move up front. Ln of e is 1. The natural log of e is 1. So telling us x is equal to the natural log of 4. And if we type ln of 4 into the calculator, we get 1.386. 1.386. And that's it. Any questions on any of these here? Any questions over anything we've done so far today? We ready for the next one? Any question over everything we've done? So this one here is not any different. It's just going to apply a little more steps. Now here, is e already by itself? Well, yes. So that means we can go on and apply the natural log to both sides. We can apply the natural log to both sides of this equation. On the left-hand side, the 4x minus 3 as the exponent would move up front. And actually it would become by itself because our ln of e simplifies to 1. And on the other side we have the natural log of 19. And after applying that, all we need to do now is just get x by itself and we would have our answer. So the first thing we can do in getting x by itself is to add 3 to both sides, which would tell us that 4x is equal to the natural log of 19 plus 3. At this point here, we can divide both sides by 4, telling us that x is equal to the natural log of 19 plus 3 divided by 4. And again, at this point here, we can just type this into the calculator. So we can get our fraction, ln of 19, close parentheses, plus 3 all over 4 gives us 1.486. And there's our answer. Any questions over any of this here? Any questions over anything we've done so far today? Let's move on to the next type of problems. Log base 2 of 5x minus 17 equals 3. What we're going to do to solve this is the other property that we had. Which is our b to the log base b of x. Whenever the base and the base of the logarithm are the same, these here simplify out, leaving us with just x. So if we put both sides to the same base whenever we're dealing with logarithms, it'll simplify the logarithm out. So for this here, we can put both of these to the base of 2. Because 2 to the log base 2 of 5x minus 17, this part here will simplify out, leaving us with minus 17 is equal to 2 to the third power. 2 times itself 3 times. Well, 2 times 2 is 4. times 2 is 8. Now we just need to solve this here. Any questions on how we got 5x minus 17 equals 8? Well, at this point here, the next thing we can do to solve for x is to add 17 to both sides. Here will tell us 5x is equal to 25. Next thing we'll need to do to get x by itself is to divide both sides by 5. So x is equal to 5. Now with these here, we need to make sure whatever's inside the logarithm is not 0 or negative. It's not so much focused on the value of x, but what's left inside here. So if we plugged 5 back in, we would get 5 times 5 minus 17 equals 3. Now 5 times 5 is 25. And 25 minus 17 is 8. So this here is more of what we're focused on. What's left over? The 8 when we plugged 5 back in for x. Since the 8 is not 0 or negative, it means that 5 does work. 5 is a solution. All right, guys, come on. Let's wake up and put the Chromebooks away. Caleb. Trey. Let's wake up.
Sorry, my sleep.
But this here cannot be negative. Once we plug it back in, whatever that is cannot be negative. Even if both sides are true, it gives us the same thing on both sides. It does not work if we have a negative or 0 inside of a log. Any other questions on this here? Okay, let's go on and look at the next one. So we want to solve log base 3 of 10x minus 9 is equal to 4. Now to solve this here, what we need to do first is to apply a base to both sides to get the logarithm to simplify out. Since we have log base 3, we're going to put both sides to a base of 3. So we have 3 to the log base 3 of 10x minus 9 is equal to 3 to the 4th. And the reason we do that is because this here, 3 to the log base 3, will cancel out, leaving us with 10x minus 9. Yes, sir? Yes. Now the other side, 3 to the 4th power, we can do that in a calculator. We can multiply 3 by itself 4 times, giving us 81. Once we do that base of 3, now all we need to do is solve for the value of x. So the first thing we can do in solving for the value of x is to add 9 to both sides. Because negative 9 plus 9 is 0, leaving us with just 10x is equal to 90. Yes, sir.
So why would you use 9?
For the second step?
Yeah.
So we're trying to get x by itself, so it's going to be easier to simplify the minus 9 first. So we would add 9, because our negative 9 plus 9 would give us 0, getting the 10x by itself, and adding 9 over there. Yeah, we could divide by 10 first, but it's going to give us a funky decimal, because we would get x minus 0.9 is equal to 8.1. Now, over here, we would divide both sides by 10, telling us x is equal to 9. Here, we can add 0.9 to both sides, because negative 0.9 minus plus 0.9 is 0. 8.1 plus 0.9 is still 9. It still works out. We'll get the same answer. This here is a little bit easier to work with. And especially if we're starting, if it had been, say, 3x, thirds are not as nice, or 12ths, or 6ths. But sometimes nice to leave the division until the end. Does that make sense? Any other questions on this here? We can look at one or more of these here before we move on to the next one. So what base would we apply to both sides? 2. Because here, 2 to the log base 2, this here cancels, leaving us with x minus 6 is equal to 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32. Now at this point here we can add 6 to both sides, telling us x is equal to 38. And 38, if we plugged it back in, would not give us 0 or a negative number, so that is a fine solution. And if we did check it, it would give us the same answer. It would give us the same answer on both sides. Any questions on any of this here? Now this here looks like it's going to be a lot harder than what we've done. It's only one main step, difference. Now, last week when we talked about having 2 logs being added together, we can rewrite it as a single log. Because when 2 or more logs are added together, we can rewrite it as a single log with what's inside being multiplied together. Because whenever we have 2 or more things being multiplied together inside the log, we can rewrite it as an addition of logs. So here we can rewrite log of 2x plus log of x minus 5 as log of 2x times x minus 5. And at this point here, now we're doing the exact same thing as we did on the ones before. Now this one here, they did not write the base in, but what is the base for this log? It's understood to be 10. Because whenever we have log without a base written, it's understood to be 10. The natural log is understood to be e. So here, 10 and the log will cancel each other out, leaving us with 2x times x minus 5 is equal to 10 squared is 100. Any questions on how we got to this point here? Now at this point here, we'll need to solve, so it'll be helpful to multiply the left-hand side. So 2x times x and 2x times negative 5. Well, 2x times x is going to be 2x squared. Minus 2x times 5 would be 10x is equal to 100. So we have a quadratic, and anytime we have those x squared or degree is higher than 2, we've got to get everything on the same side of the equation, same side of the equal sign, and getting this here equal to 0. So here we would need to subtract 100 from both sides. And if we subtract 100 from both sides, we get 2x squared minus 10x minus 100 is equal to 0. Now at this point here, we would need to solve. Now we can do it in one of 3 ways. We can either use the quadratic formula, or negative b plus or minus the square root of b squared minus 4ac all over 2a. We can factor it, use a greatest common factor, and use our 2 sets of parentheses. Or we can graph it. Which way? We can factor or graph it. Now if we graph, the graph would be a little bit easier if this comes out to be whole numbers. So what we can look at is 2x squared minus
10x minus 100. So I can hit y equals, type it in, and hit graph. Because they're trying to see where it crosses the x-axis, because any spot it crosses the x-axis would be a value of x that makes the function equal 0. But we do see one. -5 is a value of x that makes it equal 0. Now, when I was looking at the graph, we do see that it comes up over here. So somewhere at around 10 or greater. Have to scroll down a little bit. And it works out that 10, it is 0. So -5 and 10. So here we can say x is equal to -5 and x is equal to 10. If we were to factor it, we would have gotten to the same answer. Now again, what's inside the logarithms cannot be negative or 0. What's inside the logs cannot be negative or 0. So if we look at -5, here we'll have log of 2 times -5 plus log of -5 minus 5 equals 2. 2 times -5 is -10. -5 minus 5 is, well, in both cases, those logs, once I plug -5 in, both give me -10. There's nothing else we can do to them, so this here does not work because we cannot have a negative or 0 inside the log when we simplify down. And when we check these, we're not checking after we made or applied any properties to them. So we're not going to be checking it at that point there where we have log of 2x times x minus 5. That's not where we're going to check it. We're going to check the original equation. Now, if we had tried this with 10, we'd have log of 2 times 10 plus log of 10 minus 5 is equal to 2. Well, 2 times 10 is 20, and 10 minus 5 is 5. So we have log of 20 plus log of 5. 20 and 5 are both positive numbers, and they're not 0. So that works for us there. If I wanted to, I could grab the calculator, so I can quit, and say log of 20 plus log of 5 and hit enter, and indeed it tells me that it's 2. So for this here, the correct answer is x is equal to 10. And that's all we need to do for this here. Any other questions on any of these here? We're going to stop here because we've got about 3 minutes left of class. We'll finish these note sheets up tomorrow, and we'll finish 6.63. 6.63 has 3 problems. And the only difference from today and what we're doing tomorrow is it's this type of problem, except it's not going to be addition, it's going to be subtraction. That's the only real change.